Okay, so in the tutorial 9, from the second question, you have rigid pavement. So this rigid pavement question will be in 2 weeks. This week and the tutorial 10 also will be, we are proceeding with one question. You need to, like, whatever the things that we calculate, we will be using it in the tutorial 10 as well. Okay. So the way of the design part is different in rigid pavement because the load is distributed differently. We don't calculate ESAs or SAR7s here. Instead, we are finding equal axle repetitions. So I'll explain you that part here when we do the question. So here, the first question is, they have given us the site A. We will be, as I have mentioned, we will be using this site A throughout the whole question, even in next week. So they have given us the CBR values of your subgrade. First part that we need to do is evaluating the subgrade and finding this equivalent subgrade CBR. When you consider your subgrade, you have done soil, am I right? Have you done that proctor test where you are dropping in a practical? Have you done that? You're dropping a weight and that so you have realized that the number of blows that you need for different layers will be different because the CBR value will be different. So here they say depth to the bottom of sublayer. So we can see up to at 0.2 meter depth, the CBR value is 6. And also they are saying at a depth of 0.5 meters, the CBR value is 5. At a depth of 0.7 meters, the CBR value is 4. And at a depth of 2 meters, the CBR value is 3. So this is what they have given in the table. To our calculations, we can't have these different CBRs. Instead, we need to have a CBR equivalent value, like an average value. To find this equivalent value, we only consider the first 1 meter. We don't have to go beyond that. So we only consider up to the first 1 meter. And we have an equation to calculate it. So that equation is this. So here, HI is your thicknesses. So if you consider the thicknesses, what is the thickness of the first layer? 0.2 meters. Next one, 0.3, because these are the depths. These numbers are the depths. That's the depth from the top. So this layer should be what? 0.2, and this layer should be, we are going up to 1 meter. So it should be 0. We are only going up to 1 meter. So that should be 0.3. So HI means these thicknesses. CBR means these ones here. So if you want to find, if you want to put the numbers in this equation here, how we can do that? So if you consider the first 0.2 meters, that times the 6 to the power of 0.333. Am I right? So your HI for the first layer, we are looking at the first layer. HI is 0.2 and the CBR is 6. Oh, yeah. And when you go to the next layer, what it should be? 0.3 times 5 to the power 0.333. Next one. 3 to the power of 3 altogether at the end. 0.2 times 4 to the power of 0.333. Then we have a 0.3 times 3 here, 3, isn't it? This one is 3, so we take it 3 here, 3 to the power of 0.333. Am I right? Then you need to divide by the total thickness. We are considering 1 meter, so that will be 1, isn't it? this HI, sum of HI is 1, and you need to take to the power of 3. When you put these numbers, what do we get? Yeah, you have a cube there, okay? So you have to. What's that? No, it should be a small value. So these are the numbers I got. 4.3. This whole part is 1.63 and divided by 1 to the power of 3. You were able to find out where you went wrong? All good? Yeah. Okay, so this value is needed for your next question as well. So anyway, any question? Are you guys okay with this? Okay, now let's move to the next part of the question. So it's the same site. Okay, so they are saying the same site A has heavy vehicle axle groups of 5 times 10 to the 7. In the traffic load distribution survey at site A, it was found that only 35% out of these 5 times 10 to the 7 heavy vehicle axle groups, 35% is single axle, single tires. Do you understand what they mean? This 5 times 10 to the 7 is all the axle types, SAST, SADT, or everything. But 35% is single axle, single tires. And they are asking us to find the expected repetitions. So we need to find out of this SAST, that is this much, out of this one, how many heavy vehicle axle groups, how many single axle, single tires are with different loadings. So how many are with 130 kilonewtons, how many are with 120, how many are with 110, like that. So I hope you are familiar with this already because we have done a similar thing last week, proportions. So if you add these ones, you get 1 because that is the proportion, or else you can say this is 32.1%, this is 33.6%, like you can make it to percentages if you want to, but they have given you proportions. So that means, for example, for 90, if you times this value by 32.1% or else 0.321, you get how many SASTs are there with 90 kilonewtons. Do you agree with me? Does that make sense? So likewise, this expected repetitions for load groups, we need to find out for all of these ones. So I just did for 90. This one I did. This is this. If you put this whole thing into calculator, you get that. But will you be able to find me few of those numbers, please? Just, you don't have to do all, okay? Just maybe few to get familiarized with the process. So if you want to do for this one, what you need to do? That will be 5 times 10 to the 7 times 35%. times 0.00024. If you put this in the calculator, you get that number. Am I right? For the 130 kilonewtons.
How would you put 34 over 100 days? Oh, the 30.
Yes, you can put either 100 or else you can put that's the same thing.
Yeah.
This part will remain the same for all the calculations. This part will remain the same. So you times this part by those proportions to find for different loads. What do we get? 4,200. Yes. So do we all get that? So these are the expected repetitions for each loading. We need this for next week, okay? We are not going to use these numbers today, but for the tutorial 10, we need this stuff, okay? So we haven't finished. We are just leaving at this stage and we are going to move to the next question, but we are using this for the tutorial 10 again. Okay, now the next question is, the design detail of the pavement of site A are as follows. So they are saying, we have a base. Do you remember the layers of the rigid pavement? So we have sub-base, we have the base, and we have subgrade. Am I right? So they are saying this base is 250 millimeters thick, and it is plain concrete. And they haven't given us the sub base yet. And they are saying the strength is 4.5 megapascals and the project reliability is 95%. Determine the minimum sub base requirement. So we need to find out the minimum sub base requirement, the thickness of the sub base, the minimum requirement, and the effective subgrade strength. So effective subgrade strength, we have a CB equivalent CBR value of 4.3. Do you remember this 4.3 we calculated at the very beginning? Yes. So, but after putting this sub base, the effective subgrade strength will be different. So we are going to find that value when we put the sub base. What will be the effective subgrade? So subgrade strength will be increased because of putting a sub base. Subgrade is your native soil. Sub base is a concrete layer that we are going to put. Make sense? Okay. So let's see how to do this one. And also they're asking us to find this load safety factor. We are finding this because for the tutorial 10, we need all this data to do the final calculations for designing the rigid pavement. So the process is different to flexible pavement. So we need to follow all these steps to do the final part. That's why we are doing this step by step. Now, if you look at these tables, so this table 9.1 from the Ostrode gives us the information about the minimum sub-base requirement for rigid pavement. Depending on our design traffic, we can find out the sub-base type that we have to use. So what is our condition? What is our design? Do you remember the design traffic? 5 times 10 to the 7, isn't it? Let's go back and say 5 times 10 to the 7. Okay, so what should be our minimum sub-base requirement? What is that? 150 lean concrete sub-base. So that will be this line here. So this table, this chart here, we can use to find the effective subgrade strength. We found the equivalent value, 4.3. Am I right? So when we put the lean concrete sub-base, that effective value, or you can find out that it will increase to this 61%. That makes sense? So this value again we need for the tutorial 10. So they're asking us to find it and we found it. All good. And in the next part, they're asking us to find the load safety factor. So depending on the project reliability and the pavement type. So we have a PCP pavement base, plain concrete base, and our project reliability is 95%. So our load safety factor is 1.3. Any question? Are we good? No questions? Okay, so we haven't finished. We found all these values because we need them next in the next tutorial. So we need this value, we need this value, and also we need these values and for our next tutorial. Okay, so we are going to use all these values for next tutorial. We haven't finished, but these are the only questions that we have for this tutorial now. Do you guys have any question? Yes.
Can we have access to the tutorial answers?
It's
Just for studies, no?
yes, the thing is I can give you, but I won't be able to put it in the